Hello everyone, welcome to this video on the top design patterns in Java. In this video, we'll be discussing some of the most commonly used design patterns in Java, along with examples of how to use them in your code. Design patterns are reusable solutions to common software development problems. They help you write code that is more modular, flexible, and easier to maintain. There are generally three categories of design patterns. Creational patterns. These patterns focus on the process of object creation, providing mechanisms for creating objects in a manner suitable for the situation. Examples of creational patterns include singleton, factory, and prototype. Structural patterns. These patterns focus on the composition of classes and objects to form larger structures. Structural patterns deal with how objects are composed to form larger structures or interfaces. Examples of structural patterns include adapter, composite, decorator, and proxy. Behavioral patterns. These patterns focus on the communication between objects, providing solutions for the assignment of responsibilities between objects and how they communicate. Examples of behavioral patterns include observer, strategy, template method, and command. Each category of design patterns has a unique set of problems it addresses and provides solutions for. In this video, we'll be discussing the creational design patterns in Java. Question 1. What is singleton design pattern? Singleton pattern is one of the simplest design patterns in Java. The singleton pattern is used when you want to ensure that only one instance of a class is created, and that this instance is accessible globally throughout your application. Here's an example of how to implement the singleton pattern in Java. In this example, the singleton class has a private constructor, which means that it can only be instantiated from within the class. It also has a getInstance method that creates a new instance of the singleton class if one doesn't already exist, and returns the existing instance if it does. This ensures that there is only ever one instance of the singleton class in your application. Question 2. What is factory pattern? The factory pattern is used when you want to create objects without exposing the instantiation logic to the client. In other words, it provides an interface for creating objects, but leaves the actual creation of those objects up to subclasses. Here's an example of how to implement the factory pattern in Java. In this example, we have an interface called shape that defines a draw method. We also have two classes that implement the shape interface, circle and rectangle. We then have a shape factory class that has a static getShape method. This method takes a shape type argument and returns an instance of the appropriate class based on that argument. This allows us to create objects of different classes without having to know the specific implementation details. Question 3. What is abstract factory pattern? This factory is also called as factory of factories. Abstract factory lets a class returns a factory of classes. So, this is the reason that abstract factory pattern is one level higher than the factory pattern. An abstract factory pattern is also known as Kit. Steps to implement abstract factory pattern. 1. Create main class which call factory of factory class. Point 2. Factory of factory. Factory producer creates instance of factory class. Point 3. Factory class returns required class instance. Question 4. What is prototype design pattern? The prototype design pattern is a creational pattern that allows you to create new objects based on existing ones, without the need for explicit instantiation. In other words, you can create a new object by cloning an existing object rather than creating a new one from scratch. This pattern is useful when creating new objects is expensive or when you want to isolate object creation from the rest of your code. Here's an example of how to implement the prototype pattern in Java. In this example, we have an abstract prototype class that defines the clone method. We also have a concrete class concrete prototype that extends the prototype class and overrides the clone method to return a clone of itself. Finally, we have a client class that creates an instance of the concrete prototype class, clones it, and prints the name of the class of the cloned object. Question 5. What is builder design pattern? Builder pattern refers to approach that focuses on constructing a complex object from simple objects using step-by-step approach. Major roles used in this design patterns are complex object, complex object which we will generate with builder design pattern builder, abstract class or interface that defines all ways to create the product. It also has get final product method that will finally return complex object. Director controls complex object creation. It has two main goals. First, to call appropriate concrete builder class to create correct complex object. Second, to return that complex object. Here are the simple steps involved in implementing the builder design pattern. Create a class with a private constructor and private variables representing the properties of the object you want to create. Create a separate builder class as a static inner class of the object class with public methods to set each property. Each method in the builder class should return the builder object to enable method chaining. Add a build method to the builder class that returns the fully constructed object. In the main code, use the builder to set the properties of the object and call the build method to create the final object. I hope this video has been helpful in explaining these design patterns in a simple and easy to understand way. Thank you.